Hello students, I am continuing with the question answers of NCERT book of the chapter 1 motion. Page number 103, question number 3. Question: a train starting from a railway station and moving with uniform acceleration attains a speed of 40 km per hour in 10 minutes. Find its acceleration. A train is starting from rest. A very important point to be remembered: whenever a body is starting from rest, its initial velocity is equal to 0. So the first point here, initial velocity u is equal to 0 and attains a speed of 40 km per hour. So what is this 40 km per hour? Starting from rest means u is equal to 0 and attains a speed means v is equal to 40 km per hour. Final velocity v is equal to 40 km per hour. In the previous class I told you kilometer per hour is not the SI unit. It must be meter per second. And I told you the conversion also. Multiply by 5 upon 80. When kilometer per hour is multiplied by 5 upon 18, it will become meter per second. So this is meter per second. 40 and 18 can be cancelled. 20 into 500. 40 and 18 got cancelled. 20 and 9. So 100 upon 9 meter per second. And the time t is given in 10 minutes. Time is equal to 10 minutes. And we know that minute is also not the SI unit. SI unit of time is second. So this minute is to be converted into second. So 10 into 60 seconds, that is 600 seconds. So we have u, we have v and we have t. And what is the question? Find its acceleration. Acceleration a is equal to question mark. U, v, a, t. Which equation relates u, v, a, t? First equation of motion relates u, v, a, t. So using first equation of motion. Using first equation of motion, and the first equation of motion is v is equal to u plus at. V means 100 upon 9, u 0, a unknown, t 600. That is 100 upon 9 is equal to 600 a. Cross multiply. 9 into 600 a is equal to 100. A is equal to 100 upon 9 into 600 is equal to 1 upon 54. Or you can change it into decimal. 1 upon 54. .18 meter per second square. So answer is 0.18 meter per second square. I hope you understood. Always remember to convert each of the given things into SI unit. Kilometer per hour into 5 upon 18 meter per second. Minute into 60 second. So this is the solution. Next is page number 107. I hope there are no questions before that. Yes. Page number 107. Question number 1. What is the nature of the distance time graph for uniform and non-uniform motion of an object? Already taught. The shape of distance time graph for uniform motion is a straight line moving upwards. And for non-uniform motion, it is a curve moving upwards. So the shape of distance time graph for a body with uniform motion is straight line moving upwards, and for non-uniform motion, it is a curve moving upwards. Question number 2. What can you say about the motion of an object whose distance time graph is a straight line parallel to time axis? Already been taught in my previous class. If dt graph is a straight line parallel to time axis, what does it mean? Only time is increasing, distance is constant. When will it happen? Same distance but time increases. When will it happen? When the body is at rest. So the answer is body at rest. See my previous video. Question number 3. What can you say about the motion of an object if its speed time graph is a straight line parallel to time axis? Again my previous video. If speed time graph is a straight line parallel to time axis, what does it mean? Time increases but speed is constant. So the answer is constant speed. If Vt graph is a straight line parallel to time axis, it represents body is moving with constant speed. Question number 4. What is the quantity which is measured by the area occupied below the velocity time graph? Again, taught earlier, the area occupied below velocity time graph is distance travelled. Area occupied below velocity time graph represent distance travelled by the body in time t. So that's all. Now page number 109. Question number 1. These are numericals. There are 5 questions. All the 5 are numericals. So I will solve it one by one. First question. A bus starting from rest. Again starting from rest. As soon as you hear starting from rest, you can write u is equal to 0. Moves with a uniform acceleration. Uniform acceleration means a is equal to 0.1 meter per second square. 0.1 meter per second square. For 2 minutes, time t is equal to 2 minutes. But it must be in second. 2 into 60 second is equal to 120 second. Find A. First part, the speed acquired. Now there are 2 parts. In the first part you are asked, find the speed acquired. What do you mean by speed acquired? What will be the notation? What will be the symbol? A body is starting from rest and you are asked to find the speed acquired, means final velocity. V is asked. So V is equal to question mark. UATV. Once again, first equation of motion. Using first equation of motion, V is equal to U plus AT is equal to 0 plus 0.1 into 120. 120 into 0.1, that is 12. So the answer is 12 meter per second. The speed acquired means final velocity V, and we got the answer V is equal to 12 meter per second. And there is a B part also. B, the distance traveled. Now what is the symbol for distance travel? S. So S is equal to question mark. Now we have U, A, T, V and S is us. Using second equation of motion. S is equal to ut plus half 8t square is equal to 0 into 120 plus half into a 0.1 into t square. T is 120 square. 0 into 120 is 0. Half into 0.1 into 120 square, 12 square, 144. 0, 0. 144 and 2 can be cancelled. It is 7, 2, 0, 0 into 0.1. So 7200 into 0.1, 10 is gone. Answer is 720 meters. So S is equal to 720 meter. All of you see once again the solution. For the first part we have used first equation of motion. For the second part we have used second equation of motion. Now question number 2. A train is travelling at a speed of 90 km per hour. Brakes are applied so as to produce a uniform acceleration of minus 0.5 meter per second square. Find how far the train will go before it is brought to rest. What does it mean? A train is travelling at a speed of 90 km per hour. After applying the brake, it is coming to rest. So U is equal to 90 km per hour is equal to 90 into 5 upon 18 meter per second is equal to 5 into 5, 25 meter per second. It is coming to rest. So V is equal to 0. And uniform acceleration of minus 0.5. So acceleration A is equal to minus 0.5 meter per second square. Find how far the train will go before it is brought to rest. How far means S. So S is equal to question mark. UVAS. Which equation relates UVAS? Third equation of motion. So using third equation of motion, third equation of motion, 2AS is equal to V square minus U square. 2 into minus 0.5 into S is equal to 0 square minus 25 square. 2 into 0.5 is 1. 1S is equal to 0 square 0, 25 square 625. So minus 625 or sorry 2 into minus 0.5 is minus 1. Here there is a minus sign. So minus 1s equal to minus 625. Minus got cancelled. S is equal to 625. Therefore, distance travelled by the train before it is coming to rest is equal to 625 meter. The answer is 625 meter. So, don't forget to put the signs wherever it is required. Here there is a minus sign, so answer will be minus 1s equal to minus 625. Then this minus and minus will get cancelled. So the answer is 625 meter. Now question number 3. Question number 3 is a trolley while going down in an inclined plane has an acceleration of 2 centimeter per second square. Acceleration is given in 2 centimeter per second square. We know that this is also wrong. Centimeter per second square is not SI unit. SI unit is meter per second square. So how can you convert centimeter into meter? 2 centimeter equal to 0.02 meter. So it is 0.02 meter per second square. What will be its velocity 3 seconds after the start? After the start means the body is starting from rest. Again u is equal to 0. What will be its velocity means v is equal to question mark. After 3 seconds. So t is equal to 3 seconds. AUVT. Which equation relates AUVT? First equation. So using first equation of motion, what is asked? V is asked. V is equal to U plus AT is equal to 0 plus 0.02 into 3. 3 into 0.2, 0.06 meter per second. So the answer is V is equal to 0.06 meter per second. Now question number 4. Is a racing car has a uniform acceleration of 4 meter per second square. So acceleration is given 4 meter per second square. What distance will it cover in 10 seconds after the start? After the start, again u is equal to 0. What distance it will cover in 10 seconds? So t is equal to 10 seconds, and what is asked? What distance it will cover? S. AUTS. Which equation? Second equation of motion. So using second equation of motion, S is equal to ut plus half at square is equal to 0 into 10 plus half into 4 into 10 square. 0 into 10 0 plus half into 4 2, 2 into 10 square, 2 into 100, 200. So the answer is 200 meter. The distance travelled by the body is equal to 200 meter. So all these are simple numericals. First of all, you have to write what is given in the question and what is asked in the question. Then you see among the 3 equations of motion, which equation relates all of them together. Apply that particular equation, substitute the values. Now the last question, question number 5. Question number 5 of page number 110. Now it is in page number 110. A stone is thrown vertically upward with a velocity of 5 meter per second. So what is that? Initial velocity. A stone is thrown with a velocity, so that is initial velocity. Initial velocity is given 5 meter per second. If the acceleration of the stone during its motion is 10 meter per second square in the downward direction. This is a very important point. whenever a body is thrown upwards, its acceleration will be negative. Why? We will come in detail in the next chapter of gravitation. Whenever any body is thrown upwards, Earth is pulling it backward with an acceleration. So, the body moving upward has always negative acceleration or retardation. That's why its speed decreases as it goes up. Automatically its speed decreases because every body going upward has retardation. Earth is pulling it back with an acceleration. So, whenever we take the acceleration of the bodies going upward, it will be taken with minus sign. Remember this point. And whenever a body is coming downwards, its acceleration will be taken with plus sign. So here the acceleration of the body going upward is given minus 10 meter per second square. Remember this point. Whenever the bodies go upward, its acceleration will be taken with minus sign because it is actually retardation. What will be the height attained by the stone and how much time will it take to reach there? Two things are asked. Up to what height it can go and what time will be taken by this stone to reach there. Now, when this stone goes up and after reaching a particular height, it will stop there and it will fall down. So, whenever a body is thrown upwards, after reaching a height, it will stop there. What does it mean? Its final velocity will be 0. So, very important point to be remembered. For all the bodies throwing upwards, final velocity will be 0. So, UAV, and what is asked? Find the height attained. Height means S. UAVS. Which equation connects the third equation of motion? Using third equation of motion, 2AS is equal to V square minus U square. 2 into minus 10 into S is equal to 0 square minus 5 square. Minus 20S is equal to minus 25. 5 square 25. Minus got cancelled. S is equal to 25 upon 20 is equal to 5 upon 4 is equal to 1.25. 1.25 meter. So, this is the first answer. This body will reach up to a maximum height of 1.25 meter. This is the first answer. Second question is asked, what is the time taken by the body to reach there? How much time will it take to reach there? Now the second part is asked, T, time taken to reach there. Now, we have two equations, either the first equation or the second equation connecting with T. Either you can use first equation or you can use second equation. V is equal to U plus AT is a similar equation. So I am using first equation. V is equal to U plus AT. V 0, U 5, A minus 10 into T. So it is taking 5 to this side. Minus 5 is equal to minus 10t. Minus got cancelled. T is equal to 5 upon 10 is equal to 0.5 seconds. So this is the second answer. Time taken to reach the maximum height is 0.5 second and the maximum height reached is 1.25 meter. So an important point to be remembered here is, whenever the bodies are thrown upwards, it will stop after reaching a maximum height. So its final velocity is 0. When coming down, its acceleration is, for the bodies going upward, acceleration will be taken with minus sign. For the bodies coming down, acceleration will be taken as plus sign. So please practice all these numericals. This is the application of equations of motion. We will come with more numericals in the exercise. Now the exercise questions are left. That will be done in my next video. Till then, practice the things that are taught today. Take care. Bye bye.